Hello, and welcome to this pre-recorded event for GCE Statistics S2 6684. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. Hard copies of the question paper and the mark scheme are essential to get the full benefit from the feedback. During the session, we will take a look at candidates' performance in each question, and will consider common mistakes. You will have the opportunity to allocate marks for some of the questions, and to compare your mark with the agreed mark. Let's make a start and look at question 1. Overall, this question was well done. In Part A, the vast majority of candidates were able to gain full marks. However, any errors that arose were generally from writing the probability of y greater than or equal to 10 as 1 minus the probability of y less than or equal to 10, or as 1 minus the probability of y less than 9. Or simply not looking up information correctly in the tables. Part B was well completed. Most candidates were able to gain full marks here, and most used the Poisson formula as opposed to the tables. The most common mistakes were finding the probability of y less than or equal to 2 rather than the probability of y equals 2, or using an incorrect value of lambda. A curious error was to approximate 1.8 by 2 to allow the question to be solved by the use of tables. This scored 0 marks. In Part C, most candidates realized the normal distribution was required and remembered that the mean should equal the variance. Problems arose in applying the continuity correction, with 470 and 470.5 being popular wrong roots, although 468 and 468.5 did make a number of appearances. Overall, a good proportion of candidates knew enough to use the correct continuity correction and standardization. On the next slide, there is a response to one Part C, to which you should allocate marks using the mark scheme. Press pause on this slide and allocate marks using your copy of the mark scheme. When you are ready, press play to check your marking against the agreed mark. As you can see from the slide, this response achieves 4 out of the possible 6 marks. The student has realized that a normal approximation is required, with a mean and variance of 450, and so gets the first 2 method marks. They have also realized that a continuity correction is needed, but have standardized using the incorrect value of 470.5. However, they get a method mark for standardizing using an allowed value, and another method mark for realizing that a continuity correction is needed. They then lose the accuracy marks, as their answers for both the Z value and the final probability are incorrect. How many marks would you give to the response on the next slide? Again, press pause, try marking the response, and then press play to check your marking on the next slide. On this complete question 1, they score 6 out of 11. In Part A, they have misread the tables. In Part B, they are completely correct. In Part C, although they know that the normal approximation to the Poisson is required, and they know the correct continuity correction, they have interpreted the second value in the normal distribution notation to be the standard deviation, resulting in an incorrect Z value, and hence incorrect answers. This one error has cost them 4 marks. We will now move on to question 2. Part A proved challenging for many students. Putting the expression probability of 5 being less than or equal to x, which in turn is less than 11, into an equivalent form that can be applied to the cumulative binomial tables, that is, the probability of x less than or equal to 10 minus the probability of x less than or equal to 4, led to many varied wrong expressions. In Part B, although there were many students who got 3 or 4 marks for this part, there were few getting full marks. As detailed in the slide, there was usually a slip on some aspect of conducting a hypothesis test. The most serious error was finding the probability of x equal to 1, rather than the probability of x less than or equal to 1. The central feature of a hypothesis test is to establish the probability of an event as bad or worse than that observed, under the conditions of the null hypothesis, and in this case, the relevant event is x less than or equal to 1. On the next slide, we see examples from 2 different responses to the mistakes described above. You may wish to press pause on this slide in order to see how the marks have been awarded. When ready to move on to question 3, press play. In question 3, Part A, whilst most got full marks using the standard method given in the mark scheme, a few candidates, some of whom were successful, used an alternative method. Anticipating Part C, they found the cumulative distribution function capital F of x in terms of k and a constant c. A minority thought this was a discrete distribution, and tried to find sigma x times the probability of x. For Part B, successful candidates generally used a sketch. Those candidates who did not tended to think the mode was 6. In Part C, most got the cumulative distribution function for the first part of the function between 0 and 2, and also stated the function correctly for values less than 0 and greater than 6. For line 3, dealing with the function from 2 to 6, most candidates neither used capital F of 2 equals 1, nor the alternative method given in the mark scheme. They merely just integrated the second part of the probability density function and obtained an incorrect constant. For Part D, most students put line 3 of the cumulative distribution function equal to 0.75, often obtaining a quadratic equation. However, some added lines 2 and 3 of the cumulative distribution function before equating to 0.75, thus leading to a cubic equation. Very few of the candidates getting a quadratic equation, either correct or incorrect, made any attempt to solve it. On the next slide, there is an opportunity to allocate marks to parts C and D of question 3. Press pause on this slide and use the mark scheme to allocate marks to parts C and D of question 3. When you have finished, press play to compare your mark with the agreed marks. As you can see, this response earns 3 marks out of a possible 9. They have obtained the method and accuracy mark for the second line of the cumulative distribution function. However, their attempt at the third line, using the second alternative, did not include limits 2 and x on their integral, thus losing both method and accuracy marks. They do earn the B mark for correct first and fourth lines. In the last part, they do obtain a quadratic equation which they attempt to solve, but it was obtained by equating their line 3 to 0.25, thus losing both method and accuracy marks, as the second method mark is dependent on having scored the initial method mark. We will now move on to question 4. In parts A to C, most candidates scored full marks. Parts B and C could be obtained directly from the formula book, although a few students integrated in part C in contrast to using the formula. Students who correctly identified part D as being a binomial situation with n equals 30 and probability of success as being either 0.2 or 0.8 generally were successful, although, as in question 1, there were some who had problems in identifying the correct inequality to use. In part F, there were many correct solutions. The main error was to use the normal approximation to the binomial rather than the Poisson approximation. In this situation, the normal approximation is not appropriate, as the probability of success from part E is 0.04, and the binomial approximation needs a success probability near to 0.5. On the next slide, we see a response to question 4 which gains 11 out of the possible 12 marks. As you can see, parts A, B, C, E and F all get full marks. In part D, however, they have stated that the probability of x greater than 0.4 is 0.1, and then have stated that what they call L is approximated by a binomial with n equals 30 and p equals 0.1. They get the B mark for this, although if they had not made the initial statement of x greater than 0.4 being 0.1 in this part, and had just stated the binomial approximation with 30 and 0.1, then they would have lost both the B mark and the M mark. They then correctly identify that with this approximation, they require the probability of x less than or equal to 3, so get the M mark. They lose the accuracy mark as they get the wrong answer. In fact, they looked up the value in the cumulative binomial table for n equals 10 and p equals 0.1. We will now move on to question 5. Part A was answered well and showed a good understanding of a critical region. A few wrote their critical region as a probability, but only rarely was an interval given as between two values, or the critical values of 0 and 9 stated on their own. For the candidates who did not give a correct critical region, it is worth noting that to get the first method mark, a probability from a Poisson distribution with a parameter of 4 needs to be written down as evidence of using such a distribution. In Part B, there were many who did not state their hypotheses, nor give their conclusion in the context of the question. In particular, the mark scheme required the word lifts for all to be given in the conclusion. In D, although there were many good solutions, it required candidates to keep a very clear head about what they were counting. The problem was not one of subject knowledge, nor was it one of technical competence. The challenge was in interpreting the question and devising a suitable strategy. Many started this part well and gained the first 3 marks. However, many then used the binomial distribution incorrectly to obtain the 2 required probabilities. Some did not realize that 2 probabilities were needed, or misapplied the binomial formula. On the next slide, there is the opportunity for you to see if you can apply the mark scheme to question 5. Press pause on this slide and award marks to this response using the mark scheme. When you are ready, press play. This slide shows that the marks allocated for this response would be 7 out of 12. You may wish to press pause to see how the marks have been allocated. When ready, press play, and we will continue to question 6. In Part A of this question, most candidates realized that the integral of kx to the power n between the limits x equals 0 and x equals 1 was equal to 1, although sometimes the limits appeared later. Similarly, in Part B, most realized that they were integrating xk x to the power n, but errors due to misunderstanding the laws of indices were quite common. Part C was usually answered correctly by those who had successfully answered Parts A and B. In Part D, a minority was still unable to distinguish between the expectation of x squared and the variance of x, and whilst most correctly used the variance of 3x equal to 9 times the variance of x, a high but significant minority for S2 thought that the variance of 3x was equal to 3 times the variance of x. On the next slide, you should pause the presentation and allocate marks for this example of question 6. Press pause and mark this response to question 6. When you are ready, press play to see the agreed marks. As you can see in this slide, the student has obtained full marks for Parts A and B. However, they have quoted an incorrect formula for the expectation of x squared, and have lost both marks in Part C. In Part D, they have stated that the variance of 3x is 9 times the variance of x, gaining the second M mark, and then have correctly calculated the variance of x, ignoring their incorrect answer in Part B for the expectation of x squared, getting the first M mark in the scheme. Unfortunately, they have substituted the wrong value for the variance of x, so losing the final accuracy mark. Hence, they end up with a final mark of 8 out of 11 for this question. We will now move on to the last question on the paper, question 7. In question 7, it was pleasing to see many completely correct solutions. However, a small number of candidates made no progress beyond establishing the probabilities of each coin separately. For those candidates between the above groups, it was often a case of errors due to omitting significant details. For example, the problem seen most often was omitting the triple 10, 20, 50 from the cases with a median of 20. Of those students who included this triple, many multiplied it by a factor of 3 rather than 6. Whilst adopting an inefficient strategy did not matter as such, it obviously takes up more time. One group of candidates created a huge list, effectively a table with 4 columns, consisting of the triple, the median, calculation of the probability of this triple, and finally the result of this calculation. There were often 27 lines in this table. Other common errors included using a shorthand of 1, 2, and 5 for the medians 10, 20, and 50, but forgetting to convert back at the end, or finding the probability of a median of 10 only by conventional means, then subtracting this from 1 and dividing the resulting probability by 2 to give the alleged probabilities for medians of 20 and 50. Just because the probabilities of x equals 20 and x equals 50 are equal, does not then mean the probabilities for the medians of 20 and 50 are also equal. Finally, using the mark scheme, see if you can mark the following response to question 7. Press pause on this slide and mark this response. When ready, press play. As you can see, this response gets 5 out of the possible 7 marks. They have written down the probabilities of picking each denomination of coin and have identified the possible medians. They have then shown correct calculations for the probabilities of medians of 10p and 50p and have obtained correct answers for these. For the 20p, they have missed out the triple 10, 20, 50, thus leading to an incorrect calculation and answer for the probability of a median of 20p. Thus only 2 out of the 3 final probabilities are correct. We will now take a look at some of the reasons that successful candidates did well and why some students were not so successful in the exam as a whole. This slide gives some of the reasons that candidates were successful. It always makes a positive impression on the examiner when working is set out in a clear and logical way. This paper involves the use of several probability distributions. Successful candidates invariably made clear the distribution being used. Many errors were generated by reading the wrong value from statistical tables. Successful candidates took great care to make sure they were reading the correct values. Statistics is very much related to the real world, and we expect students to relate their answers, where appropriate, to the real-world situation in the question. this slide, we see some of the possible reasons for students being less successful in this exam. An untidy script with no clear method given, and where the examiner is searching round for the answer, does not help the candidate. Showing the method will usually pick up method marks, particularly when the final answer is wrong. In S2, hypothesis testing is an important topic, and a clear understanding of the meaning of null and alternative hypotheses, critical region, 1 and 2 tailed tests, and significance level is essential. Many candidates lose marks unnecessarily by misreading statistical tables. Although this occasionally involves reading the wrong table, more often it is a case of writing down an adjacent probability to the one required. Candidates should double-check that they have the correct row and column in the table. In question 6 of this paper, many weaker candidates showed that they were not confident with the laws of indices, which is a topic in C1. This was often combined with leaving expressions such as 1 to the power n plus 1 and not simplifying them to 1. Such mistakes are disappointing at this level. Well, that completes the feedback for the June 2015 S2 paper. We hope that you have found it beneficial. The final 3 slides give links where further information can be found regarding overall grade outcomes for Edexcel examinations, grade boundaries, and details of the changes to GCSE and GCE subjects for first teaching in September 2015. Pause this slide if you wish to note down any details. GCSE English subjects and Maths are changing for first teaching in September 2015, with first assessments in summer 2017. GCEs for a range of subjects are changing for first teaching in September 2015, with first assessments in summer 2017. We have published our specifications on the Edexcel website. We are also running a series of launch events too. Our specs and SAMs, as well as further information about our launch events, can be found on edexcel.com. Other GCSE and GCE subjects will follow in 2016 and 2017. Thank you for watching and participating in this pre-recorded presentation. We always wish to improve the training we provide. You will shortly receive an email directing you to our online feedback form. The form takes no more than a couple of minutes to complete. Please help us to improve by letting us know your thoughts by filling in this short form. Thank you once again.